This is lesson 1.7 on the distributive property, and we're going to throw a little bit of stuff on like terms in as well. The learning target for today is to use the distributive property to simplify expressions. Now, if I give you an expression that looks like this, 3 times parentheses 1 plus 4, most of you would just say, oh look, there's parentheses, I'm going to add 1 plus 4 together, and then I multiply 3 times 5 and get 15, and that's the correct way to do it. You might also notice, though, that there's a 3 on the outside of a set of parentheses, and this indicates that you're going to use the distributive property. The distributive property just means that you're going to distribute this 3, or give it, to each part inside. So you're going to distribute it to the 1 and then to the 4. And when you distribute, you're multiplying. So it's 3 times 1 plus 3 times 4. 3 times 1 is 3, plus 3 times 4 is 12. 3 plus 12 is 15. Same answer. Now, if I were you, I'd be asking myself the question, why would I ever want to do it this way when this way is so much easier? And the answer is you wouldn't do it this way because the other way is so much easier. But this is a demonstration of how the distributive property works. When do you use the distributive property? When you have an example like this one. So copy example 1 in your notes. This problem says 7 times x plus 8. And the reason you'd use the distributive property is because you can't add x plus 8 together. They're not like terms. So you have to distribute. So when you distribute the 7 to the x and the 7 to the 8, you get a new expression. Now I'm going to show you how to write it out, and some of you will say, well, do I have to do it that way? Yes, for this assignment I want you to write out each step. So here it is. 7 times x is just written 7x, 7 times x, plus 7 times 8. 7x is just 7x, plus 7 times 8 is 56, and that's your answer. Notice the problem is written, there's one step in between, and then your answer. And I'm going to change this to a positive 9. Now sometimes we'll get tricky on you and we'll put the number on the outside of the parentheses, but we'll put it on the back side. The concept is still the same. You're still going to distribute the 9 to each term inside the parentheses. You're just distributing backwards. So in this problem, I'm going to multiply 9 times the first number, which is 4, plus 9 times the y. And notice I didn't put a little dot between the 9 and the y. I didn't put the y in parentheses because a letter next to a number is implied to be multiplication. 9 times 4 is 36, plus 9 times y, or just 9y, and that's your answer. Okay, moving on. All right, the third example has some negatives in it, and there's a couple things that are happening here. The first thing that's happening is there's a negative sitting outside of the set of parentheses. And that negative really just means -1. But I'm going to just suggest to you that you just leave it as a negative. The second thing that's happening is there's a subtraction in the middle of the problem. And in algebra, you want to change that subtraction to be adding the opposite. So in this problem, change the subtraction in the middle here to add the opposite. And again, if you've never seen that before or are confused on that, make sure you mark your notes and ask me when you get to class. So the negative on the outside gets distributed to each term on the inside, and you're going to write it out. Negative times -3 plus negative times -2z. This negative is this one and this one. A negative times a negative is a positive, so the opposite of -3 is +3, plus a negative times a negative is positive, so 2z, the answer is just 3 plus 2z. Okay, second part of example 3, part B. Same situation. Outside of the parentheses you have a negative, only this time it's a negative number. On the inside you have a minus, so I'm going to change that to add the opposite, and then you're going to distribute the negative 5 to the negative 3 and the negative 5 to the negative 2z. Write it out. Negative 5 times negative 3 plus negative 5 times negative 2z. When you multiply negative 5 times negative 3, a negative times a negative is a positive, so that's 15, plus negative 5 times negative 2z, a negative times a negative is a positive, so that's positive 10z. And that's it. That's your answer. Okay, for this next part, I have 3 terms for you to copy down definitions. So I'm going to reveal all 3 terms. You should hit pause on the video, copy these definitions into your notes, and then I'll talk about them. All right, I've assumed you've written down the terms, and coincidentally, the first term is term. And a term is just a number, a variable, or a combination of numbers and variables. So 4 is a term. It's a number. 7n is a term. It's a number and a variable, so it's a combination. And n is also a term. It's just a single variable. Now if I take these 3 terms and I put them into an expression where I'm adding them together, now I have an expression that has 3 terms. 1, 2, 3. In an expression, a term is usually separated by an addition or a subtraction. The next word up here is constant, and it's just a term with no variable, or in other words, it's just a number. So in this expression, 4 is a constant. It has no number next to it. 7n and n is not a constant. It's got a variable in it. And then the last term, coefficient, just refers to the number part of a term. In this term, 7n, the number part of it is the 7. So the coefficient of this term is 7. In this term, there is no number, so you'd think, well, it doesn't have a coefficient. But whenever you have a letter without a number in front of it, it's implied to be a 1. So the coefficient for this one is a 1. Okay, so for this example, example 5, and you'll notice that I've skipped example 4. So make sure you're numbering your notes correctly. Example 5, this is an expression. How many terms are in this expression? You should be answering yourself, and your parents are probably thinking, why are you talking to yourself or talking to the computer? There's 2 terms separated by an addition. And in this case, both terms have an x squared in it. And because they both have an x squared, that makes those 2 like terms. And you can add like terms together, and when you do, you only add the coefficients, 12 and 3. So to add these 2 like terms, you add 12 plus 3 and get 15 x squared. Notice I don't do anything to the x squared. I just add the coefficients when I'm adding like terms. Here's another part of example 5, part B. How many terms are in this expression? Again, you should be answering yourself. There's 1 separated by addition, 2 separated by subtraction, 3, and 4. Now as you look at this expression, do any of these terms have the same exact variables with the same exact exponents on them? The answer is no. This one has an x squared, this is a y, this has both x and y, and this has none. There are no like terms in this expression, so you can't do anything to it except call it good. That's the answer. All right, last example, part C. How many terms in this expression? 1, 2, 3, 4, 5 terms. Some of the terms are like terms. So the way I like to do it is I start with the first term. It has an x in it. I'm going to circle it. Then I look through the rest of the expression and find every other term that has an x in it. Here's one. And with that, I'll circle the negative sign. Then I go back and I start over. 7y. I'm going to put a box around the 7y. It has a y in it, so I'm looking for any other term that has a y in it, and here's one right next door. The last term is just a constant, so it's all by itself. Now I can add like terms together. 8x minus 3x is 5x. 7y minus 5y is plus 2y. And then I just add the 9 to the end, and that's my answer.